Hi, hello, welcome back to VSM Math tutorial. Today we are going to discuss about the basics of calculus. So in this session what we are going to do, we are going to study the basic formulae, the basic properties of the differentiation in terms of addition rule, subtraction rule, multiplication rule and division rule. Also we will deal with some integration problems also. So let me start with basic formula in integration. Okay. So basic formula. Basic formulae. What are those? The first one is polynomial. So what is polynomial? Algebraic terms. Okay. We have x and y. So first, if we differentiate d by dx of x power n. So what is the formula says? So it is n into x power n minus 1. Now, if you remember this formula, you can easily solve problems without any problems. Now for example, now if I want to find out differentiation of x power 8. So if we know this formula, just n value is 8, so it becomes 8 into x power 8 minus 1, that is 8 into x power 7. Or d by dx of x power 15. So when we have term like this, then it is 15 into x power 15 minus 1, that is 14. This is positive powers. If I consider negative powers also, differentiation of x power minus 10. What happens? Minus 10 into x power minus 10 minus 1. That is minus 10 into x power minus 11. Now these are all direct questions, x power 8, x power 15, x power minus 10. Sometimes we may also deal with problems like this, x power 8. So when problem given like this, what you are supposed to do, you have to bring this term to numerator. So in that time, what happens it is x power minus 8. So once it is converted into x power minus 8, we have formula. Okay. So just we operate this formula, minus 8 into x power minus 8 minus 1. So it is minus 8 into x power minus 9, or if we write in other way, it becomes x power 9. So this is the basic formula in differentiation, that is polynomial differentiation. This is the formula. I have taken all the three types of possible examples. One is positive power, negative power and reciprocal, means p by q form, 1 by x power 8. When problem is given in this form, you have to bring this to numerator, then you have to operate the same formula, you have to differentiate, you will get the answer. Okay, this is the fundamental formula in mathematics, especially in differentiation. So now we will move on to the exponential terms, that is differentiation of exponential term. So that is second important formula, d by dx of e power kx. If I differentiate exponential term, so what happens? It is k into e power x. This is again one more important formula. Here also I will consider all the three possible examples. Example, if I consider differentiation of e power 2x. If I differentiate e power 2x, a value is 2 here, so it becomes 2 into e power 2x. Or differentiation of e power minus 6x. So what happens? A value is minus 6, so it is minus 6 into e power minus 6x. Now this is direct power, positive power, negative power. I will take one reciprocal, 1 by e power 10x. Some of the students, they are facing the difficulty if they are given like this. So it is very simple. you just bring this term to numerator. That's it. So it is d by dx of e power minus 10x. So it becomes minus 10 into e power minus 10x. This is how to differentiate an exponential term. So if we remember this formula in differentiation, then we can deal with umpty number of problems. Okay. Now the third one is logarithmic function. So that is differentiation of log x. It is direct answer. Log x differentiation is what? 1 by x. Polynomial over, exponential over, logarithmic over. Then we will come up discuss trigonometric terms. We have 6 trigonometric functions. We write all the formula. So that is differentiation of sin ax. I consider sin ax differentiation is what? A times cos ax. A times cos ax. Differentiation of cos ax. So that is minus a sin ax. Differentiation of tan ax. So that is secant square ax into differentiation of base term, that is a. So it becomes a times secant square ax. And if we remember these three, then remaining cot, tan, cot, cosec, cosec to reciprocals, we can somehow manage with them. Okay. So these are very important fundamental formula in differentiation. Differentiation of polynomial, differentiation of exponential term, differentiation of logarithmic term, and differentiation of trigonometric term. And also differentiation of all constants. Let it be k is constant. Differentiation of constant term is always 0. Differentiation of constant term is always 0. If we remember, we can easily solve problems. I will just randomly take few examples. Differentiation of sin 6x. So what happens? Differentiation of sin 6x. We know a value is 6 here. So it becomes what? That is 6 times cos 6x. And differentiation of cos 8x. So it becomes what? Minus 8 times sin 8x, because differentiation of cos is minus sin. And sometimes purposefully the problem will be given like this: differentiation of sin of minus 3x. So it becomes what? Minus of differentiation of sin 3x. That is minus of sin 3x differentiation 3 cos 3x. Differentiation of cos of minus 2x. This is very important. It becomes differentiation of cos 2x itself. Here some students will commit the mistake. Please remember the trigonometry, that is what it says: sin of minus x is minus sin x. But cos of minus x is plus cos x itself. Plus cos x. Therefore, cos of minus 2x is nothing but cos 2x. So it becomes minus 2 sin 2x. Like this, we can easily solve more number of problems. So these are all just the basic formula and simple problems. Okay. Now I will move on to the rules of differentiation. Basic rules of differentiation. There are 4 rules which are very, very important and useful in differentiation. Okay, so we'll study one by one. The first one is addition rule. Addition rule. So what it says: if u and v are any two functions of x, or any two functions of x, then we have so differentiation of u plus v What is differentiation of u plus v? This differential operator is applicable for both the terms, that is du by dx plus dv by dx. Okay. Similarly, if we have a minus here, so it is holds good for minus also. For example, if I take simple example, differentiation of x square plus some e power x. So how to, so it is in the form u plus v form. So we have to operate differential operator separately. It is differentiation of x square plus differentiation of what? E power x. So differentiation of x square is what? 2x, and differentiation of e power x is what? E power x. Very simple concept. Many of the students, they feel that differentiation is very difficult like that, but it is very simple concept. Okay. Now I'll take one more example. Differentiation of some sin x minus x cube. I have taken plus here, I have taken minus here. So what happens it is, if we operate separately, so it is differentiation of sin x minus differentiation of x cube. So differentiation of sin x will be what? Cos x minus differentiation of x cube. It becomes what? 3x square. So that is the answer. So what addition rule says, if we have any two functions of u and v with addition or subtraction, then the differential operator is applicable for both u and v. Means it is also like linearity property. Okay. So now these are the examples with respect to addition or subtraction rule. Now I'll move on to the next important rule, that is multiplication rule. Same. If u and v are any two functions of x, then we have multiplication rule. What it says, d by dx of u into v. So it becomes what? U into dv by dx plus v into du by dx. Means if we have product of any functions of x, then by keeping one function as it is, we are differentiating other function, plus by keeping other function as it is, we are differentiating the first function. So it is holds good for three functions also. Means if w is also one more functions of x, uvw. So how to write as u into v dw by dx plus uw into dv by dx plus u v and w, that is du by dx. Okay. So now this is how we are differentiating the product of any functions. It is with respect to two functions, it is with respect to three functions. Now let me take simple examples here. Example, differentiation of x square into sin 2x. Differentiation of x square into sin 2x. You see here, there are two functions. X square is one separate function, sin 2x is other function. If I differentiate by product rule, so I'll keep first function as it is, x square as it is, and I'm differentiating the second function, that is sin 2x, plus sin 2x I will keep it as it is and differentiating the first function, that is x square. So now what happens? X square as it is, sin 2x, we know sin ax, that is a cos ax. A value is 2 here, so it is 2 cos 2x plus sin 2x as it is, then x square differentiation will be what? 2x. So if possible, we can simplify it further. See, both sides 2x is common. So if I take 2x outside, here it is x into cos 2x plus sin 2x. So this is how we are operating product rule. Okay, it is very simple. If we know know the basics properly, then the problems are very simple. Okay, as I said, the first step is formula. You have to remember formula. If you are good in formula, then basic rules. Now you will see everywhere rules, formula. That's it. Okay, nowhere we are doing derivation or something else. To solve basic problems in engineering, the basic knowledge of the differentiation is important. Okay, so that is the reason. Please study all the basics properly. Now I will take one more example. D by dx of log x into some e power 2x. Now you see here again, any two functions of x here, product is here, we have to operate product rule, that is log x as it is, differentiation of e power 2x plus e power 2x as it is, differentiation of log x. So what happens answer? So log x into e power 2x differentiation is what? 2 into e power 2x, because we know e power ax differentiation a into e power ax plus e power 2x as it is, log x differentiation 1 by x. If we were to simplify it further, e power 2x is common on both sides. If we take e power 2x outside, what is remaining? It is 2 log x plus 1 by x. Dear student, this is how to operate product rule or multiplication rule for any two functions or three functions of x. Now we will move on to the last rule, that is division rule. Okay. So again, I am considering two functions u and v, any two functions of x. Then what division rule says? Now, if I have any two functions of x which is in the form u by v, then what division rule says? Division rule says denominator square, then denominator into differentiation of numerator minus numerator into differentiation of the denominator. This is what the division rule. Now, let us study this rule with one example. Simple example I will consider. Differentiation of some cos 2x by x. We have any two functions here, cos 2x by x. So what happens if I operate division rule? So division rule says denominator square. So denominator square, denominator term into differentiation of the numerator, that is cos 2x minus denominator kept as it is, differentiated numerator, and numerator keep it as it is and differentiate the denominator. Now you see here it is x cos 2x differentiation minus 2 sin 2x, because we know cos x differentiation is minus k sin x, a value is 2 here, minus 2 sin 2x minus cos 2x into differentiation of x will be 1 divided by x square. So if we simplify it further, there is no common on both sides, we will write as it is, minus I will take outside, so it becomes what? 2 times x into sin 2x plus cos 2x divided by x square. Some student will commit the mistake, that is very rare mistake, that students may multiply this x and this x, that is wrong. Okay, don't do that because it is free term, this is under the function, you cannot multiply them. Okay, so this is how we are operating the division rule with respect to any two functions. If you want, I will take one more example so that you can easily understand this division rule concept. D by dx of e power 2x divided by sub cos x, if I consider. See, they may give any type of functions, do not bother. You just know the method and formula properly. Keep on doing the problems using them. So what it says, denominator term, that is cos x whole square, denominator term cos x, that is v, du by dx, that is differentiation of numerator e power 2x minus u, that is numerator e power 2x into differentiation of denominator, that is cos x. This is equal to cos x differentiation of e power 2x, that is 2 into e power 2x minus e power 2x, differentiation of cos x is what? Minus sin x. Divided by, it becomes cos square x. So here e power 2x is common on both sides. If I take e power 2x, what else? 2 times cos x, minus into minus plus sin x, because e power 2x from the both the terms I have taken outside, so remaining terms I am writing here, and this minus minus become plus into cos square x. This is the answer. So this is how we are differentiating any two functions of x which are in u by v form. So these are all the basic or fundamental rules of differentiation, and the formula what I have given here. If you practice, so definitely you can improve your calculus simplification methods. Okay, and these are very important things. So this is the first session or first lecture on basics of calculus. In the next class we'll move on to the some more important topics on calculus. It may be integration, or it may be extension of this part itself. I may take some more other examples and we will solve them. So those who are watching my channel first time, kindly subscribe my channel. Those who are already subscribed, kindly press the bell button for notification, and your motivation, your support is always very, very important for me. Okay, I hope you enjoyed this video. So thank you all.